Thank you. Hello, everyone. Good evening. My name is Daniel Rosenwasser. I'm the program manager on the TypeScript language at Microsoft. Great being here in Paris. I was hoping it would be closer to the US elections, so I could run away if I needed to, but you know, make do with what we have. So a lot of you have probably tried using TypeScript at this point. If you've used Angular 2, you're probably familiar. If you're still using Angular 1 and you're thinking about upgrading to Angular 2, though, you may not be familiar with it. And so I want to tell you a little bit about TypeScript and why we made it. And the reason that we made TypeScript started from a pretty basic core idea, which is just that big JavaScript applications are hard. And it's not necessarily just big JavaScript applications, it's small and medium-sized applications that kind of grow and grow over time, organically, you might say. And a lot of the time when we say organic, something grew organically, it's like a good thing, right? Like I went to the store, I bought this apple, it's organic, it's good. But if you have a code base that grew organically, you probably want to burn that down. It's not a good thing in software. And we kept running into this situation at Microsoft where we would just build these code bases in JavaScript and they would just become this unmaintainable mess. And this was not something that was unique to us. This was something that we were seeing, you know, others were seeing at Google. As web applications got more and more complex, we just knew that the problem was going to get worse and worse for everybody. And we thought about the problems we were running into, and we thought about why we didn't see it in other languages, and we realized that the issue was that JavaScript on its own was not enough. It's not that JavaScript was like a terrible thing that needed to be destroyed. It's really just that JavaScript lacked a couple of things that we thought were fundamentally helpful for building well-designed systems. And so, you know, for instance, we were missing things like modules and classes that helped us group together related functionality and methods and all that. And we were also missing this concept of keeping different parts of your application in sync, keeping them, you know, holding them to a contract or just having a common understanding of what your application should have, what methods any object has, what properties, how they're named, things where if you rename something, you'll know if something is going to go wrong in another part of your application. And really, that's all that types are. Types are just that foundational thing that tells whether or not any change is going to interrupt another part of your program's expectations. And when you've actually built those up, you can create great tooling around that as well. And so we just took a look and we said, well, why don't we just take JavaScript and add all the things that we were missing, like types and tooling and features of future versions of JavaScript that are, you know, like classes and modules and all that, and let's build a language out of that. And that's how we got TypeScript. And so TypeScript is an open source, cross-platform superset of JavaScript. And when I say superset of JavaScript, well, all I mean is that it's a superset of JavaScript, not Java, not C#. It's not trying to turn JavaScript into a completely different language. It's still JavaScript at its core. And when I say superset, really all I mean is that it's just JavaScript with types and some other goodies. And so it's really this language that if you're using JavaScript today, you're already familiar with it. You can already call yourself a TypeScript programmer. Now, one of the big things that we had initially was, you know, a pretty good system. We had a great editor support, as long as you were on Windows, right? If you were on Mac or Linux, the story was a little bit, not grim, but, you know, it wasn't as pleasant. And so when we met with the Angular team, you know, when AdScript was still kind of a thought, we wanted to understand why TypeScript couldn't be the language at the time. And so one of the problems was that there was just not enough good tooling for TypeScript on Mac and Linux and for platforms that all Angular users were using. And so we kind of put our heads down and worked on Sublime Text, a Sublime Text plugin, so that we could just see how this experience would end up. And the experience actually ended up being pretty great. People really liked this thing. So we were able to extract the core of that and create TS Server, which is just a server, a background process that listens for commands from your favorite editor and just answers with information like, where is this function defined? Who uses it? And things like that. And so the great thing about this is, as long as your editor has a plugin system now, you can basically use TypeScript anywhere you want. So if it's, whether it's Atom or VS Code or WebStorm or whatever, you can get a great TypeScript experience. And for that, this might get a little mushy, but we really, really love the Angular team and the Angular community for making us a part of it, right? This has been, pushing us in the right direction from the start, and it's been a great experience. And again, like I said, it can sometimes get a little bit mushy, but we're really, really quite serious about this. We gave a presentation at an Angular conference with my coworker wearing a Angular onesie. So keep that in mind. We're very committed to this. So enough about that. Let's actually dive into some code. Now, can everyone see this? Okay. Let me know if you can't. So this is going to be a pretty basic example. We're going to do what I kind of like to call a code review. So the idea is I want you to look through this code for a little bit and try to find any glaring errors that you can. And if you can't see anything, that's okay. I don't really expect anyone to, right? I want to see if anything pops out for you. This is an API that you haven't played around with or a new code base that you haven't seen before. But what I'm trying to get at is that if you haven't actually seen anything, you might miss this in a code review. So first things first, I want to actually, let's make this bigger. Is that better? A little more or more? Okay. Okay. So first thing is I'm going to actually just convert this into a TypeScript file, right? And all that involves is switching this J in the file name to a T. All of a sudden, you see these red squiggles underneath everything. And I don't want anyone of you to panic. These red squiggles don't mean the same thing you've seen in maybe other languages. You should think of them more as when you're writing in a Word document, right? You can still print out your Word document. Everything is still okay. And so just to show you, what I'll do here is I'll start up the TypeScript compiler in watch mode on the TS file. And again, you see the red squiggles. And if we look side by side, we can just take a look at what the compiler produces. The emit is pretty much identical except for the spacing and the indentation. So it basically tries to do a faithful conversion of your JavaScript. Now, let's take a look at the first error that we have. It says that read-only does not exist on a property descriptor. And so we're not really sure what that means. So let's actually go to where defined property is defined. It takes us to a file called lib.d.ts. A d.ts file is what we call a declaration file. This is just a file that describes to TypeScript what exists at runtime. It explains these things exist in JavaScript. I'm telling you about them. And lib.dts is just a description of what your standard library looks like at runtime. So you have things like object.create and object.defineProperty. And for defined property, the third parameter is a property descriptor. So we jump into that. And we can see that it has these, it's a type, it's an interface, with optional properties like configurable, enumerable, value, writable, etc. So we look back at original code, and it says read-only false. Well, if we look here, I have writable. So what I probably meant to do instead of read-only false was writable true. And you'll see I got another error. If you notice while I was typing, I actually got a suggestion for writable. And it turns out that writable doesn't have an E in the name. So we got rid of one red squiggle. All right, let's take a look at another one. It says that HTML element isn't assignable to a string. Well, getElementById returns an HTML element. ParseInt takes a string. So what I probably meant to do was get the text out of this HTML element, whoops, text, and pass that to parseInt. All right, next one says, whatever I'm giving to this thing here needs to be a number or an enum or an any. You know, the long story short is it caught this really trivial mistake where what I really meant to do was see if this thing was null or undefined or empty, and then just replace that with the string standard. And when I want to do that, I want to use the double bar, the logical OR operator. So we have no more red squiggles. If we look here, we've gotten rid of them in the command line. And I didn't have to add any types yet, right? All we did was change a J to a T. But let's actually add a type annotation. So we look at email address, and it has the type any on it right now. Any means that you can literally do anything with it. You can call it, you can construct it, you can get a property on it, you can do whatever you want, right? So if we look at the documentation, the JS doc here, it says that it takes a string or an array of strings. So I'll just copy that, and the way that it works in TypeScript is if you want to say it's a string or an array of strings, you write it out just the same way. And as you can see here, now we have 2 more red squiggles. And again, this is not a problem. We'll just go through and find out what's wrong. So it says for each doesn't exist on a string, and trim doesn't exist on an array of strings. And that's kind of weird. Basically, oh, I haven't done the correct check here to check whether or not this thing is an array. What I probably should have done is array.isArray. And now, in this branch, TypeScript knows that this thing is an array of strings, and this thing is a string in the other branch. One last red squiggle. It says trim doesn't exist on a number. Well, if we look at val, it says that val is a number. Well, if we look at index, it's a string, and easy mistake, we just mix these things up. So notice I just got rid of all these errors that were very, very, hidden from us, kind of. They were undercover, and all I had to do was just change a J to a T and add one type annotation. So as you add more of these types, you sprinkle them throughout your application, you get better and better checking to avoid these sorts of mistakes, these common pitfalls. So you might say that's a contrived example. Well, yes, but I want to actually show you what it's like to move your existing Angular 1 code base into TypeScript now. So let's get out of here. Let's move on. And if a lot of you are familiar, there's the Angular phone cat example. This is the example that you see when you first start using Angular, just to get an idea of what an Angular 1 app might be structured as. So when we look here, we have a phone list component, and we have a phone list component, and then we have a phone detail component here as well. And so what I want to do is I want to actually start moving more and more of this to TypeScript. Once you're using oh, sorry, let me actually make this bigger. I want to start moving this over to TypeScript because once I've actually started using the component API in Angular 1, I want to actually move that to TypeScript so it'll be easier to migrate to Angular 2. So what I'll do here is I'll actually use TSC init with module kind of none. I'm not currently using a module loader. I think that if you're not, you should consider using one after you've migrated to TypeScript. But for the purposes here, we'll just use TSC init, and that'll create our tsconfig.json file. And this is just a config file for TypeScript to know the sorts of options that you want to use. You can add more and more options if you want to actually tighten the bolt on TypeScript and make you catch more errors. So let's go into phonelistComponent.js. First thing is I'm going to turn this to a TS file. I'm also going to use VS Code to start a build task. And it's going to say there is no task runner, so I'll actually ask it to put this thing into watch mode. And I'll say build. I'll also tell this to serve up so we can see that things are actually working. Okay, so we have phonelistComponent.ts. Notice we don't have any red squiggles. Also, notice that it's not giving any errors about Angular not. I'll get back to this in a minute, actually. But let's see if I can make this easier to read. Okay, So what this actually involves is taking this constructor function and moving it into a class, right? So if we want to turn this into more canonical TypeScript, we would actually create a class called phone_list_controller. And then what I do is I'd actually move the body here into the constructor of this class. And now it's going to say phones and order prop don't exist. So what I'll just do is I'll define phones. I haven't really given much thought to the type of phones at this point, so I'll just say as type any. And you should do that sparingly, but you know, as you need to go along, it can be handy just to say it's of type any. So I say order prop is of type string, and then I want to actually move this thing I'm injecting into a static inject variable. And with that, I can replace this entire thing with the controller class. So phone list controller. Now this thing is recompiling, and I can open up Chrome and look at localhost. And we can see that things are still working beautifully. So I can do the same thing with a slightly more complex one, the detail component, right? I do the same thing. I create a class. And you'd start to notice that this is a very mechanical transformation. It's a matter of moving this thing into the constructor body and adjusting to that. So let's redo that. And then, let's see here. Oh, I just ripped that off. So, okay. Let's move this down here. Phone detail controller. You don't necessarily have to do the $ inject. I'm going to actually skip that in the interest of time. And also, I just realized I haven't converted this to a TS file yet. So, whoops, sorry. And now I'll start seeing, again, the squiggles. And so this is just a very simple thing. We're not sure what the type of phone is at this point, but setImage is a function that takes a URL, which is a string, and then returns nothing because it's just modifying. And then we have main_image URL. And so, you know, this may not buy you a lot initially, but as time goes on, you can actually refactor this to make it look like more canonical TypeScript code. For instance, we can move setImage into a method. We also have arrow functions, so we can avoid doing this self-capture thing. So let's just change all these to this. Let's get rid of that. Let's turn this into an arrow function. And let's get rid of that entire line. And then it says I've defined this twice, so we get rid of that. And so it starts to look more and more like a canonical. This is starting to look a lot more like Angular 2, right? It's starting to look more familiar like the thing that we want to move towards. So that's the nice thing. What is that? What is going on there? Huh. Missing a curly brace. There we go. Thank you, everyone. Okay, awesome. And so, again, look here. Everything's still working just fine. We don't have to worry about this stuff. So you can easily put TypeScript into your code base and not have to fret about this stuff. So let's go back here now. I just showed TypeScript in action. For 2.0, we released 2.0 about a month and a half ago now. With that, we came out with a bunch of great new features like tag unions, read-only properties, non-nullables, and control flow analysis for types. One of the biggest things that people have enjoyed is our new declaration file acquisition story. So, for instance, it used to be that if you wanted to get declaration files, you had to run these 3 different commands, basically, to get there. And that could be a pain. Now, what we wanted to do was consolidate on using a dependency system that people were already using. So we wanted to get rid of that, and we moved towards a better model, we think, that relies on NPM. So if you ever had problems with using typings or TSD in the past, that could be a real pain point. But NPM makes it simple because you can already use skills you already have and leverage those. So now all you have to do is npm install -s at type / whatever library that you're using. And that's really handy because it just kind of follows that whatever library that you're using, you just prefix it with @types. With 2.0, we also brought, well, we wanted to fix this problem, which is nullable types. So in TypeScript, it used to be the case that any type that you had included undefined or null implicitly, right? This was a cause of a lot of problems because you never were sure whether or not you had null or undefined, and so any of your functions, you had to do these extra checks. So again, let's just get rid of that problem because these cause so many issues in practice. So what we did was we actually took undefined and null and moved them into their own types, each named undefined and null. And so whenever you want to actually specify that something is a number or undefined, you can use a union type like we did before, that thing with the bar. And we can just say that something is a number or undefined. So that's actually really simple and catches a whole class of errors. And I encourage you for any new projects to use non-nullable types. It's behind the flag just to not break people and keep things forward compatible. 2.1 will be coming out soon. With that, we have async await in the pipeline. And we were originally a little bit cautious because we didn't want to have any sort of speed degradations as a result of it. Turns out for a lot of projects it's actually faster now, so that's a really nice plus. We've got better inference in the works. We'll have some content out about that when we release our RC in the near future. Object rest and spread is something that we're trying to get in for 2.1 at this point. It's slated, and it's going to be great if you're trying to do a lot of copying and immutable programming, and some new tooling that's coming in the works as well. I want to talk a little bit about object rest and spread. We have, just to show a couple of examples, if you've used array rest or spread, it basically follows the same way. You have, if you want to copy an array, you just do, brackets ... x, so that copies x. Same thing with object. If you want to copy obj, you just do curly braces ... obj. Similarly, when you want to concatenate two different arrays, you'll do ... a, ... b. Merging two objects is very similar. So these constructs follow, and these are actually new features from future versions of JavaScript that are really handy. And so we're always very community-oriented. We always love hearing from our users. We'd love for you all to get in touch, get on our Gitter channel, be in contact with us on Twitter, and Gitter and our issue tracker and all that stuff. I will have code for this talk later on tonight, if I can. And since I have a little bit more time, I want to just launch into another quick demo, if that's okay with everyone? Yeah? Awesome. All right. So let's launch into, get out of here. Okay. So much output. So let's open up shapes, because shapes are fun. So I have these two types, circle and square, right? Circle has a radius, and square has a side length. And then we have a shape type, which is either a square or a circle. We're going to write a get area function. And basically what I want is for this code to actually continue working throughout that. So what I want to do is I want to actually write switch. So the idea is that whenever I have a circle, I'll have a kind with the string circle here. And if I have a square, it'll have the string square with a side length instead of a radius. So if I do shape.kind, then I will do case circle, and then I try to return math.py times shape.radius squared. And this is the exponentiation operator that came out in ES7. Except, what's this? Radius doesn't exist on a shape because it doesn't exist on a square. Basically, it can't tell which of these two it is. And so, TypeScript is trying to warn you that you don't know necessarily that you have a square at the time, or sorry, a circle at the time. What we can do is we can actually switch these to use string literal types. A string literal type is literally just is a type that specifies that only a string can encompass that type space. So here, what this means is that when circle has the kind field on a circle can only be the string circle, and similarly, the kind field on a square can only be a square. Now notice that in this branch, TypeScript knows that you have a circle and that radius is available on it. In fact, if I dot off of this, it actually exposes radius now. And outside of here, well, since I already returned from the branch of the circle, and I know I either have a circle or a square, I can return shape dot, and now I have side length because it knows that I have a square in this branch. So, and I can square that. This comes in really handy when you need to discriminate on, this is called a tagged union. Basically, you have a union here, and each of these has a common property, which we'll call a tag. And in this case, kind is the tag. We've also called it discriminated unions. We've also called this algebraic data types. We can't pick a name, so tagged unions it is. And this comes in handy if you're thinking about combining Angular with Redux or something like that, if you're thinking a functional approach to things as well. It's a very powerful technique. And in fact, I can show you something like that, where you have a person, which has a name, string, which is a city, which is a string, and then age, which is a number, and then I want to modify person. Actually, I feel like we've already taken a look at tagged unions. So let's try something else, something better. Who here is familiar with implicit any errors or no implicit any? Okay, good chunk of the crowd. So it used to be the case that if I had no implicit any on, TypeScript would complain. And in this case, the idea is that TypeScript can't figure out what the type is from a certain inference site. It can't figure out what the type should be because I haven't given it enough information. Here, it knows that it's an array of an array of numbers. But right now, it has to say that it's an array of any. However, the problem is that you don't know what you're going to do with that array later on. So we're trying to improve our inference process. And so now, if I push 1 into the array, I know that I have an array of numbers. And similarly, if I push a string, then TypeScript knows that I have an array of strings or numbers. And so this is great because the reason that TypeScript gave you an implicit any error is because it couldn't figure out the type and you could actually feed any into anything else. But now it actually knows that if you try to feed, you have a function that takes a Boolean. Oh, that's also f. X is a Boolean. If I try to call g with x, then it knows that, sorry, let's get the first element of that. It knows that a Boolean is not assignable to a string. It knows that you're going to be doing the wrong thing with it. So instead of just kind of throwing its hands in the air, TypeScript will now actually go out of its way to figure out your types at any of these positions. This is really powerful if you're moving an older code base into TypeScript now, because you don't have to change the way that you code. So this is something that we're really excited to experiment with more and more as we go on and make TypeScript a more powerful language. So again, thank you very much for having me. I appreciate it, and thanks.